Okay, welcome to the video notes for the next lesson in topic 12-2. Is it a right triangle? Pythagorean triples. So in this video, we're going to be deciding, are we dealing with right triangles? Remember in the first video, we learned about the Pythagorean theorem, and then when we do some practice in class, you'll see how it works. When you do some of the practice on your own, a squared plus b squared equals c squared. I can determine if a triangle is a right triangle using the Pythagorean theorem, and use the Pythagorean triples to create other right triangles. So we'll learn about what Pythagorean triples are, and we'll be using the Pythagorean theorem to decide if triangles are really right triangles. So I've got some examples, just quick ones to talk about on this page. So when I'm looking at this picture and looking at the question, which triangle is a right triangle, how do you know? So remember, we can always use a squared plus b squared equals c squared as a test to see. So when I'm looking at this triangle here, I know that this is a leg and this is a leg. So these two smaller sides are legs. And I can kind of tell from the picture that this should be the right angle, and that means this would be the hypotenuse. Now, if I connect the dots and create the squares, here I have, now side A is 2, but that makes this a squared equal to 4. And side B is b squared is also equal to 4. And then, now you might be saying, well, what are you going to do about that one? Actually, watch what I do. I'm going to connect horizontally and then vertically. And then I'm actually going to finish connecting all the other dots the way that they were intended. And what you see is 1, 2, 3, 4 in the middle, and then 1, 2, 3, 4, 5, 6, 7, 8 halves. But 8 halves is another 4. So c squared is equal to 8. So this is the right triangle. Now, when I'm looking at this other one over here, one of the problems is I cannot tell which side is the longest side. Actually, this side and this side look like they are the same. So if I have an isosceles triangle like this, and this is the shorter side, in other words, the two sides that are the same are the longest, there is no hypotenuse. So this one is not a right triangle. Now, we could test the Pythagorean theorem, but the only side I know is this one down here, and I have no idea what the lengths of the other sides are. So this is the one that's tricky to do. So it's just kind of an interesting example to look at. So over on page 8, do the following lengths form right triangles? Basically, to answer that question, we're going to test them all in a squared plus b squared equals c squared. First, identify your a and b, and then c. Now, how did I know which sides to label a and b? Remember, those are interchangeable. You can switch those. C has to be this side. Why? Well, first of all, it looks like if this is the right angle, which it looks like it is, then the hypotenuse is always across from it. The other thing you know is the hypotenuse is the longest side, and 10 is obviously bigger than 6 or 8. So now I'm going to test a squared plus b squared equals c squared, 8 squared plus 6 squared equals 10 squared, 64 plus 36 equals 100, 100 equals 100, and it checks. So the first one is a right triangle. Why? Because the Pythagorean theorem works. Okay, now, Square root of 7, square root of 9, and then the number 4. Which is which? Well, if you plug in the square root of 7 or the square root of 9, you'll find that they are smaller than 4. The other thing you can do is say, well, 4 is the square root of what number? And that would be 16. So this is the same as square root of 16, which is bigger than the other two. So this is A, this is B, this is C. So plug them in. A squared plus B squared equals C squared. So I have the square root of 7 squared plus the square root of 9 squared equals 4 squared. Now this is kind of tricky, but when you plug it into your calculator, you're going to see that squaring and square root undo each other, and you're left with 7. And here you're left with 9. And 4 squared is 16. And 7 plus 9 is 16. And 16 equals 16, meaning this is a right triangle. Dun, dun, dun. Okay, now this one's a little easier to tell which ones are the legs and which one's the hypotenuse. 16 and 30 are shorter than 36, so there's our A, B, and C. I'm going to switch the color up here. So I've got 16 squared plus 30 squared equals 36 squared. 16 squared is 256. I'm sure you all remember that. 30 squared is 900. And 36 squared, 1,296. 256 plus 900 is 1,156. That does not equal 1,296. So, what does that mean? This is not a right triangle. Why? Because the Pythagorean theorem did not work. If the Pythagorean theorem is not true, then it is not a right triangle. Okay, a Pythagorean triple is a set of positive integers, A, B, and C, that fits the rule, A squared plus B squared equals C squared. So here we've got 3, 4, 5. Now, if you plug in 3 for A, 4 for B, and 5 for C, you'll get 9 plus 16 equals 25, and that's true. Same for 6, 8, 10. Now, if you notice, 6 is 3 times 2. 8 is 4 times 2, and 10 is 5 times 2. So these are all multiples of the 3, 4, 5. Same with the next one, and technically same with this one. Now, I don't like this example because 3 radical 3, 5 radical 3, and 4 radical 3 don't fit this. These are not integers. It is a triple, but it's not what we're looking for. Here's another example of a Pythagorean triple, a 5, 12, 13. This 5 squared is 25, 12 squared is 144, and 13 squared is 169, and 25 plus 144 is 169, so this is true. So this says create 2 triangles for the 5, 12, 13 Pythagorean triple. I'll give you one example, and then you're going to do 2 more on your own. How about 10, 24, and 26? See if you can figure out what I did and come up with 2 more on your own. Also, on the next 2 pages, you're going to determine if the side lengths are right triangles. If they are, show your work. If they are not, see if you can give a reason why. And then on the following page, you have another example. And then here's the answer key for these problems. Actually, on the previous page. All right. So, if you had any trouble with any of these problems, go back and rewatch the video, or come and see me for help. Good luck, and we'll see you in math.